Hi, this is Roger from Kanka Labs today with another multimeter first look at and teardown. Now, in my search for a good pocket multimeter, 2 weeks ago I tested this relatively cheap Unity UT120C. Not come out very good because one of the most important functions, the continuity test, simply is unusable because you can't hear it. It's just unaudible. So I thought, well, let's give another brand a try, and because the Anengs tested quite favorable at David L. Jones' EEV blog and in some other channels, I thought let's give the new AN8009 a chance. The model before, the AN8008, is by some considered as the best pocket multimeter you can buy, or small multimeter. But if you compare this, it looks like it doesn't really qualify as a pocket multimeter, but I think it still fits into your shirt pocket. Compare this to the Unity, which is in size larger, but the thickness is a bit smaller. But anyway, I think for me, this is still a pocket multimeter, and it has superior functionality. And we'll take a look step by step, tear it down, make a few measurements to see, for example, here, this is true RMS, or it claims to be. We will check this, and we will especially check if it is true RMS AC or true RMS AC plus DC, because that makes a big difference. So it might look, the LCD might look a little bit dim for you, but in fact it's brighter than it looks like on your screen. So let's take a look. First of all, what you get as accessories. You get this little, how is it called, a pouch with a temperature probe. That's very outstanding because it also can measure temperature. And you get, as for probing, you get these standard probes, even with the safety things here which you can pull off. So these are the standard probes, and they are reasonably sharp, but there is one little downside, and they are rated as Cat 2, 600 volts, while the multimeter itself is 600 volt Cat 2, 1000 volts, 600 volts Cat 3 and 1000 volts Cat 2 rated. So also quite superior to many other multimeters in the $20 or euros range. And you get a whole lot of kind of configurable probes, which it was new to me. That you get this combination. So here you have a pair of red and black leads, and you can screw on the alligator or crocodile clips. You can screw on, and you have two pairs of them, as you can see here. You have these extensions here for if you need some longer. That is Cat 1, 1000 volts. And you also have shorter probes and little spade adapters and 4mm banana plug adapters. So this is really quite nice, and I would have loved to have this in my older multimeters, just this set of adapters. So quite nice. And let's plug in the standard safety probes again. Then what's also for such a small multimeter quite superior, we have a 10 amps fused current range. So that is really hard to find in such a small multimeter. So getting current measurement at all, and then an amps and a fused amps and milliamps range. that is really makes this thing quite standing out. What else do we have? It's a 10,000 counts or 9,999, so it's a true 4-digit multimeter. Also very nice. And what else do we have? The backlight is quite bright and the LCD is quite readable. You have this little stand here, which is not very stable, but better than nothing. One thing that is missing, you don't have a relative button, just for subtracting, for example, in the ohms range when you want to null out the resistance here of the leads. And you can already see what problem I'm talking of that we later see in the continuity range. So what else do we have? True RMS we already mentioned. Temperature measurement. We have quite a high resolution. I've looked it up. The amps range, or the microamps range, if you go here to, it has a resolution of 10 nanoamps. The volts, or the millivolt range, has a resolution of 1 microvolt. Also quite unique. Let's see if we can get it. Here you can see the least significant digit is 1 microvolt. So quite outstanding. The ohms range goes up to 100 megohm, also quite nice, and the resolution is 10 milliohms. That's also quite nice. 1 milliohm would have been even better to find shorts, because if you have a multimeter that can resolve up to 1 milliohms, you can easily search for shorts, which is a trick that every maker should know. Of course, it has auto power off. What I didn't test is the current consumption. We will test that later. And in the capacitor mode, the resolution is 1 picofarad, so also quite nice. So this thing is concerning the data and the functionality really for such a small and $20 multimeter. It's really outstanding, and it has this non-contact voltage beeper when you come near to an electric field. And what battery does it need? It needs a single AA cell, also quite nice. We'll take a look at that later when we open it and tear it down. And the frequency measurement goes up to 10 megahertz. Of course, this is usually only for logic level frequency measurements. So concerning the data, this thing is really, really a very good choice concerning the price and what accessories you get. So let's make a few measurements. Let's test the diode mode, if it makes blue or white LEDs light up. Alright, here we are back with an array of diodes. Schottky diode measures 0.3 volts, silicon diode measures 0.6 volts, a green LED measures 1.85 volts, and now comes the test. Oh, a white LED 2.57 volts and a blue one with 2.7 volts. So that's nice that it tests, apparently tests 3 volts open circuit voltage. Let's just check this. With you can see here the size comparison to our EEV block 121GW, and let's see what the open circuit voltage is. Yeah, 3.25 volts. So you can test all the usual LEDs, also white and blue ones. So that's quite nice. I wouldn't have guessed that. So let's do some short checks of the accuracy. Well, this Aneng is stated to be in the 1% or slightly better than 1% range, but as you can see, compared to my X-Tech 570A, which is 0.02%, accuracy, you can't see any difference. 4.9974 and 4.997 or 8 jumping around. And if we reverse the voltage, we get minus exactly the same on both displays. So I think that is quite nice. So if we go into the millivolts range, even here we're now still at the volts range and we have the same display. Now going with both into the millivolts range, we get again much better than 1% accuracy. So this is quite nice. And let's see what is when we go very low with the voltage. Yeah, 2.9 millivolts. So this is nearly identical. So nothing to complain in the DC voltage range, which is usually the one with the best specs. So next is the check for the AC voltages, especially how good the true RMS conversion is. At the moment I'm having a sine wave of 2 volts peak, which should give 0.707 volts, and both are nearly identical displays. We're now at 50 Hertz, and now I will increase the frequency 100. Now we're at 800. The Aneng is specified up to 1 kilohertz. So let's see if we get significant lower level at frequencies above 1 kilohertz. So 2 kilohertz, yeah, it starts to drop now. Okay, the frequency is really limited to 1 kilohertz, but that is quite okay. One can live with that. And now we'll change to a square wave, and we should get something around 1 volt. And you can see the X-Tech is nearly spot on. And here we are 7% off, and I think that's quite okay. What else could we check? A ramp, 0.578, 0.577 volts. So that is quite okay. So it's obviously, now I'm going to pulse. We're still at 1 kilohertz. Yeah, now we have 50% duty cycle. So this is a square wave again. I'll lower the frequency now, let's say to 50, back to 50 Hertz, because at 1 kilohertz we're really at the limit of what the Aneng can do. So we're back at 50 Hertz, a symmetrical square wave, and now I'll change the duty cycle from 50% to 40% now. And they are still quite in accordance. 30%, yeah, 20%, still only a few percent off, even less than 1% as far as I can see. 10% duty cycle, and I think this is really, the true RMS converter is quite okay. So verified that this is not cheating here with the true RMS, but now comes the acid test, when we'll go back to a pure square wave, and now we will add an offset, and we'll go here to AC plus DC. And at the moment we should get exactly 1 volt, so we're within specs. And now with 1 volt DC offset, we're getting here 1.46, and here this remains at 1 volt. Now I have 2 volts DC offset, and only the true RMS AC plus DC gives the correct value. So this is obviously only true RMS AC. So there's a capacitor which blocks any DC offsets, and if you know that, you can live with that, because there is even a formula how you, with 2 measurements, one of the DC voltage, one of the true RMS, you can even calculate the true RMS AC plus DC value. You just have to know what your multimeter really measures. Is it blocked with a capacitor to give only AC voltages, or does it have different modes? Like here we can have AC plus DC, we can have only DC, this is now the offset, 2 volts, or we can have, when we go back to pure AC measurement, always true RMS, we get again the same results. So I will give you a link down below to the difference between what is true RMS AC versus true RMS AC plus DC. But anyway, for a $20 multimeter, getting a good true RMS converter up to 1 kilohertz is really outstanding for me. So next we have the amps and milliamps ranges, and I'll change the setup a little bit. So I've connected both multimeters in series to my voltage and current generator, which is at the moment at 100 microamps, or as you can see, because this one here is more exact than my current generator, 99.75 microamps, and we get here at the Aneng 99.81, so also much better than 1%. This is just 0.1%. So let's go 1 decade up to 1 milliamps. So we're now having 999 microamps, or nearly 1 milliamps, and because the microamps range is just barely overloading, now it goes exactly to 999.9 microamps, so I will have to change to manual mode and dial in a little bit below 1 milliamps. So 910.9, 911.9. That's also again only 0.1% off, so very good result. But now comes a little disadvantage which most multimeters have. The amps ranges, they are not in steps of 10, but here at the microamps range, the maximum we can measure is 1 milliamps, or to be precise, 999.9 microamps. And if we jump into the milliamps range, where we also have to change the terminal, you can see we're now directly at the 1 amps range, or 999.9 milliamps. So if you're higher than 1 milliamp, or in the range between 1 milliamp and let's say 10 milliamps, you get very low resolution because there's just a gap in the ranges. That's a little bit sad, because the least significant digit is just 0.1 milliamps. And so if you're having 2 milliamps, you're just wasting some of the possible accuracy or precision that this thing has. So now I also have to change here. Let's give it 10 milliamps, and you can see we have exactly, we have exactly 10 milliamps. But here, because we're in the least significant digit, this is 4 digits off, but this translates already to 4 or 5% error, which is only because we have such a low display of 9.6 or something like that. Okay, we can live with that. We shouldn't complain anything here for a $20 multimeter. And finally, let's measure 1 amp and 10 amps, so the higher amps ranges. So I have to change the setup again for that. So everything is set to test the DC amps range. Both multimeters are in the 10 amps range, and we'll start with 1 amp. And we're getting, of course it's a little bit drifting at the first moment, precisely 1 amp, or 0.9993, and here again we're just 0.3% off, so a very good result. And now let's go up to 3 amps as a final result, and still just 0.3% off. So this is really a good result. The amps range, the higher amps range also is okay. We can just for a test go down to 100 milliamps, where we are now. I could even improve the accuracy. You can see the exact result is 96.19, so we're again only 0.2% of, so much better than the accuracy they state in the manual. So everybody can be happy with this thing concerning accuracy. And the last thing will be the ohms range and the continuity test. We'll leave out the other ranges like the hertz and the duty cycle measurement, which I forgot to mention. Most important is volt DC, millivolts DC, volts AC, true RMS, which frequency does it go up to, and the microamps, milliamps and amps ranges, and then of course continuity and ohms. So I have a precision better than 0.1%, 1 kilo ohms resistor connected first of all to the X-Tech, and it shows 1.0001 kilo ohms. So we can call this exactly 1 kilo ohm. And let's see what the Aneng tells us. And okay, it's 0.4%, 0.3%, it even gets better with time. So 0.2%, unbelievable how good this thing is. Now it's even getting down to nearly bang on, 0.1%, and if you wait another minute it will be probably exactly, yeah, now it's 1.000. So very good result. And finally, what I forgot to mention, if you ask, this orange thing here is of course the rubber holster, but this is only an imitation of rubber. It's just the outer or the lower part of the case. This is not a rubber holster, it just looks like. So finally, again changing the setup for the continuity testing, which is perhaps the most important thing for any multi-purpose multimeter. So concerning the usability of the continuity test, a multimeter simply needs two things. It has to be loud, it needs a loud buzzer, and it has to be fast, and the usual test is this. And you can see the X-Tech, these are the original probes that came with the X-Tech, gold plated and reasonably sharp. And you can see it's loud enough. I don't know exactly how loud you can hear it, but for me it's loud enough and fast enough. And now the Aneng, nothing. See how long you have to hold this? It's loud, even louder than the X-Tech, so there's nothing to complain about the loudness. But and I think, and that was something I already recognized before, and this could be because the probes perhaps have a problem with some oxidation. So let's just exchange the probes if the big ones here fit into these safety sockets. And you see, it's a problem of the probes. The Aneng is perfect, but the probes are not perfect. They are sharp, they are small, but they have a kind of oxide layer on top of them, and that prevents them from, you can see, they only sometimes register the continuity. And that is purely because of oxidation or oxidizing, however you want to call it. So perhaps one should get a different kind of probes, gold-plated probes, which fit here. Perhaps these probes you have to buy extra can be more expensive than the multimeter itself, because this really costs only $20 or euros delivered, or perhaps it are $25. Anyway, I paid 20 euros delivered from China or Shenzhen. And here you can see, and let's try again just to verify this, that it's really a problem of the probes and not of the multimeter. Here, perfect, perfect, just because of the gold plating. And so this thing until now is 99% perfect and really unbeatable concerning the price, the features, I even like the form factor, the weight, size, the accessories, readability of the LCD. It's really much brighter than it looks on screen. It's just as bright and as well readable as the X-Tech. There's just a problem here from the lighting, and with the backlight on it's much better. That's about the contrast you see now with the backlight that you have in reality without the backlight. So the LCD is really good. So the only thing until now to complain about is here the surface of the probes. They are sharp, that is good, but this is not good. Okay, now and finally let's tear this thing apart and thereby also measure the current consumption so that we get an impression of how long the battery holds. And another thing I discovered by chance, if we go into temperature mode without connecting the temperature probe, then we get 26 degrees Celsius displayed. So this is a true internal cold junction compensation, which is really necessary. And because I already saw this at other temperatures, like 23, this is not a fixed offset with an assumed value of 23 or 24 degrees Celsius. There's really a thermistor must be inside to give a true cold junction compensation. So another plus point, I'm very happy with that they really are building a multimeter as it should be built and not with cheating at some point. So let's see how far we get when taking this thing apart. We have a single screw for the battery compartment and the hinge here, and it wasn't one AA but instead two AAA cells. Let's take them out for safety. Then come the next 4 screws. They look like self-tapping, or feel like self-tapping screws, but that's no problem. You can't complain about anything with this 20 euros multimeter, and self-tapping screws are not that bad. So okay, this can be pressed down, and yeah, that is really a nice PCB. And look at these tiny fuses. They even look like they have a ceramic body. And this one here, 200 milliamps, 250 volts for the volts input. And this is the amps input. 10 amps, 250 volts in such a small size. I've never seen them. I don't think that they can be HRC rated, but at least they are ceramic and 10 amps rated. Really nice. Okay, here we have our 10 the current shunt, the 10 milliohms current shunt for the 10 amps range. We have our kind of standard banana input jacks, which are slotted here to give them a little bit of space for expansion, because some 4mm banana plugs have 4.1, 4.2, 3.9 millimeters, so it's quite a good idea to have them slotted. So then let's turn this around so I can read the values a bit better. These are the current shunts for the other ranges. What can we read? 1 ohms, 99 ohms. Okay, together these are the 3 main current ranges, or the shunts for the 3 main current ranges. Then we have 2 5 mega ohm resistors in series, MELF resistors as all the others. The reason is to get the CAT2 or CAT3 rating. These MELF resistors, I think they only have, I don't know, 250 volts or so per resistor. So if you put 2 of them in series with the equal value, then the voltage between them, of course, is only half as high. And so you get in total the double voltage safety margin. The battery holder is soldered directly onto the PCB. That's no problem. We have a 1N4007 probably protection diode for, let's see, yeah, here's the voltage input, although where does it go? No, it just bridges apparently the current input. We would have to trace out to find exactly. This looks here like an additional PTC. Let's see if we get any markings there. Can we read something? No, but it looks like a PTC for additional protection of the voltage input. And this little TO92 IC, it looks like here, this is the interseal logo. This could be the voltage reference. I'll just take out my magnifier. Just hold on for a second. Yeah, it's an ICL8069 standard voltage reference. So nice. What is this IC? Again, I have to take my 20 times jeweler's magnifier. That's just an EEPROM P24CO2, either with the calibration data or perhaps the whole firmware is in this EEPROM, and the magic below the blob. So, and let's see if we can get any further, if there's something on the other side of the PCB. Just all in all 5 more screws. I'm always afraid that I don't get the LCD back in place with the zebra strips or however they are, make the contact. And I think I need my metal spudgers. Here are little notches and these plastic holders, which are always a pain in the ass if you don't have the right metal spudgers to get them loose, just as we are now. Yeah, that's all. Nice switch contacts. By the way, the feel of the rotary switch, let's get back in focus, is really excellent. That is also quite nice. And I won't take here we have our zebra strips. So let's leave this LCD together because I can't see any components here. Oh, we could even, no, there's nothing more below. So part of here, the plastic was just for fixing or fastening the LCD back in place. So sorry if I'm constantly out of focus, or now we have our input jacks here even pulled out. So, but this is standard in today's multimeters. So anyway, gold plated everything. There's a little grease for the switch here. So nothing to complain about. Nice build quality, everything okay with this. The protection is for this small form factor is really excellent. You can't expect anything better in such a small multimeter. Let's get out a ruler to show you, to give you an idea of the size. These are 12 centimeters, or what is it in inches? 6 inches long, and the width is 6 centimeters or 2.5 inches. So this thing is really nice and tidy, accurate, and now I should pay a little bit more attention to getting this back in place again instead of talking nonsense in the meantime. Let me see. That was that. So let's just try out if I haven't broken anything. Seems to work. LCD is okay. Yep, the push button is okay again. Yep, everything okay. So we can get this thing back together again, and really excellent for 20 bucks. What do you expect? I've never seen such a good small multifunction multimeter, even with the most important thing, that the continuity test works really well with the right probes. And I think this is 100% recommendable. Even if you only want to get your first or your single multimeter, you can do nothing wrong. Also with the model before, this one, just to remember, is the AN8009, and the one before, the 8008, also was reviewed very favorable by David L. Jones and others. So we already verified that it's still working, though you really shouldn't do this at home, taking something down and talking and thinking and translating in your brain, because at one point or another you will make errors, mistakes, and okay, here it are only 20 euros that I could have broken. Just a final check before I put on the last part. That is this one here. And how fast this thing came apart and can be put back together again is also nice. So, very good multimeter. Just get one of these. You can do nothing wrong with for 20 bucks. And I would have never expected this quality and functionality. So I think finally my search for a pocket multimeter that I can live with and I'm happy and have nothing to complain about is finished. So thanks for watching. Until next time, bye from Roger, bye from Kanka Labs, and you can support me on Patreon if you want to.